So we've known forever, go back to Newton, that if the laws of nature were slightly different, then things would be different, like giraffes. So if gravity were a little bit stronger, there probably wouldn't be giraffes in nature, because it's already kind of difficult for a giraffe to pump blood all the way from its heart all the way to its head. So if gravity is a little stronger, there's no giraffes, there's no flying insects, things are different. What we didn't expect is that if you change gravity very slightly, and not just gravity, but a whole range of fundamental constants in nature, that life itself is impossible, and not just life on Earth, but life anywhere in the universe. So I'll give you an example. When it comes to gravity, let's just stick with gravity. So after the Big Bang, gravity is trying to pull everything back together. The universe is expanding, gravity is trying to pull everything back. If gravity had been slightly stronger, and I mean minutely, just a couple of percentage points stronger, it would have won that tug of war. The universe is expanding, gravity pulls everything back together into a point, and so you have Big Bang, but then you have Big Crunch, and the whole universe then is like one black hole, and that's it. Well, life can't exist in a black hole. If gravity had been slightly stronger, then there would be no life. And you can turn that dial the other way. What if gravity had been a little bit weaker? And I mean, very minutely weaker, percentage points, fractions of a percent weaker. Well, then the Big Bang would have produced free-floating atoms. You just would have had matter expanding and not clumping together to form gas giants and stars and things like that. Well, a universe of just free-floating atoms, that can't support life either. So gravity's a little stronger, gravity's a little weaker. In either case, there's no life. It turns out that the gravitational constant, the universal gravitational constant, is right in this tiny range, this finely tuned range, where life is possible. If you go anywhere outside of that range, then nature is radically different and life is impossible. And it's not just gravity. It's like all the fundamental forces, so gravity, electromagnetism, the strong nuclear force, the weak nuclear force. I can tell you a story, just like the one I told you, where if it's a little stronger, life is impossible. If it's a little bit weaker, life is impossible. And it's not just the fundamental forces. There are 20 or 30 examples like this, where if some constant of nature, fundamental constant of nature, is different, life is impossible. So we started discovering this 30, 40 years ago. Physicists started discovering this 40 years ago. And they generally believe this is very surprising. This is not what they thought. They did not think the universe was in some way predisposed towards life, but that's the way it looks. Fine-tuning makes it look like the universe is set up for us. And so almost all scientists and the overwhelming majority of philosophers believe this needs an explanation. There needs to be some sort of explanation for fine-tuning. So then the question is, what's the best explanation? I tend to think, and a number of theists tend to think, that God is the best explanation. The universe looks fine-tuned for life because it literally has been fine-tuned for life by God. And some people would say, well, science hasn't yet explained why these constants have the values that they do, but maybe we'll find one. Maybe we'll discover some sort of super law out there governing all this stuff, and the super law will then dictate that these constants have to be exactly what they are. And so now you've got an explanation based on this law for why the constants are what they are. They aren't free parameters anymore. And so it's just a matter of time. It's just a matter of time until science figures this out. And so, science progresses, and I can't say that this is an impossibility. The thing is, it's not looking good right now. So if you only had, say, 3 examples of fine-tuning, then you would say, okay, this is a mystery, we'll figure it out in time. But you've got 20 to 30, and they seem to be independent of one another. So in the time, again, we've had 30 to 40 years. In the time we've been looking for explanations of fine-tuning, we haven't found them. So yeah, you can put your money on future science, and that's going to do it. But that isn't the way things have been going. So you don't find a lot of people right now saying, yeah, just a matter. We can ignore it right now, and it's just a matter of time. Not a lot of people putting their money there. So some folks have said, Well, maybe one way to explain this is we don't live, that reality is more than just this single universe. Maybe reality is a multiverse. So maybe there's lots of universes out there, maybe an infinite number of universes out there. And in those different universes, these fine-tuned constants have all different sorts of variables or values for those constants. And so we just happen to live in this one universe or handful of universes where all the values come up right so that we can live. But there's lots of them out there. So there are black hole universes. You can't get to them. And I'm not talking about just like other planets or other galaxies. These are disconnected whole universes somewhere out there in reality. And so we've come to call that a multiverse of individual universes. So I think that is the most popular non-theistic explanation for fine-tuning. And it is possible. This one might work. It's just that it's not guaranteed that it will work. And here's what I mean. Just because there are even an infinite number of universes doesn't guarantee there's going to be even one where it all works out in our favor. So let me give you an analogy. Think about dice. Okay, say we're in a large stadium, the Superdome. And so there's 80,000 fans there, and we give them two. After the football game, they have dice, 5 dice in each hand, and after everyone leaves the field, they throw the dice out onto the field. Now it's going to be thousands, hundreds of thousands of dice out there. So if we now go down onto the field, it's going to be very unlikely, say, that all the dice are going to come up 5s, right? What we expect is you're going to have some 5s, but you're going to have lots of everything. And so the question is, well, how could you get all 5s? Well, this is kind of the multiverse strategy. If we keep throwing the dice, if we throw the dice, we pick them all back up, and we keep throwing them many millions, trillions, maybe an infinite number of times. If you throw the dice enough, eventually they'll come up all 5s. Okay, that's really just a matter of probability. It might take, again, nearly an infinite number to do so, but eventually you're going to get all 5s. Now, see, when I say that, you're nodding your head, you agree that this would work. But see, you're making an assumption, and you're making the same assumption that people make when they talk about the multiverse. You might not. You might never get all 5s. And one way, because what you're assuming, what my students all assume when I give this example, is that the dice are fair. If it's a fair die, if each of those thousands and thousands are regular dice like you use in games, then yes, eventually, and so when I mean fair, that each of the 6 sides has exactly a probability of 1/6 of coming up on one toss, okay, fair die. But there are loaded dice, right? There are coins also, and all sorts of games of chance that could be loaded against a certain value. So yeah, if it's a uniform probability distribution, if all the different sides of the dice are equally probable, eventually, yeah, we'll get all 5s. But if they're loaded, then it might be that we never get all 5s because the dice are set up in such a way to not want 5s, okay? So this in physics is the same sort of thing. Just because you have an infinite number of universes, they might be, in terms of whatever's producing these universes, whatever's spitting them out, might not be fair. The mechanism that produces universes might not be producing universes that are uniform with respect to all these fine-tuning values. There's no guarantee they'll randomly distribute all the values across the multiverse. And so it may be that depending on how the universes are made, yeah, there isn't even one where all the values come up that's favorable to us. And we don't know. So that would be an open question. It'd be something where you'd have to show that there is a multiverse and that what's producing, what's technically called the measure across the multiverse, is uniform across all these values to even guarantee there's one like ours. So again, the answer is even the existence of a multiverse, if there is one, doesn't guarantee, that you would have a universe like us. I should also say that physicists, something of a backlash against this multiverse idea recently in physics. A lot of physicists are feeling like they're claiming outright that the multiverse idea isn't scientific. This is really a matter of philosophy, as if that were a bad word. But it's merely philosophy because it's not empirical. You can't empirically observe these other universes out there. And so some scientists say, well, that's unless you can possibly observe something that's not a scientific hypothesis. So even now, some scientists are backing off and backing away from the idea of the multiverse being a scientific hypothesis.